Hello folks, and welcome to this techno training course. Okay, so welcome to module 1, where we're going to now talk about what ADAS actually is. Rear cross traffic alerts, area views, park assistance, surround cameras, driver alertness systems, and even highly integrated systems that tend to need some degree of maintenance or setup, particularly if something has been disturbed. Perhaps if you've hit a curb, you've put the geometry of the vehicle out, and that can then affect many other systems on the vehicle, a lot of these electronic systems, because vehicles are a very distinct possibility, and really we've got the technology to make it work today. It's just having the will to grill rather than just one in sort of the center of the grill. Now, radar stands for radio azimuth detection and range. Length of time it takes for that laser light to be reflected back to the receiver, and that means that it can calculate the distance and position of the object. Very, very similar to radar, but just using a much higher frequency laser light that is actually in the electromagnetic spectrum way above even our visible light waves. This gives some advantages over radar, in as much as it's relatively low frequency compared to things like our radar and our LiDAR, albeit it's above the sound frequency that most of us can hear. They only work over a very short distance, typically less than 5 meters. But that's perfect for things like your phone and your digital camera and your video camera these days. And they're used to capture sort of real-time data on the shape and size and detail and even color of objects. Obviously, these can be used for recording systems as well. So some vehicles do actually use the data from these to record for, crashing in use. We've got passive infrared that can simply detect that there's something containing heat in the vicinity. And they also may be able to detect that heat source has moved as well. But most of these systems now use an active infrared sensor where we're using computer enhancement technology to identify the shape and size of that object. So now we're going to move on to module 3, where we start talking about the individual systems fitted on the vehicles. Now we can use certain sensors to cover multiple systems. So this is not saying that we've got hundreds and hundreds of sensors on the vehicle, but they didn't have a cable opening and closing the throttle like they did in the early systems, because once we went to fly-by-wire throttles, or on diesel systems just completely torque demand system, then the system would give us more or less throttle as necessary to speed the vehicle up or slow the vehicle down. But a steering system, it can actually swerve around the vehicle that is in your path. Even if it can't take to another lane, it will still apply the braking system at its maximum. In the event of that happening and it's still not being able to stop the vehicle fully before an impact happens, it will at least reduce steering movement. If you do actually start to steer into the path of the overtaking or undertaking vehicle, then it will actually correct you and bring you back into the center of your lane, preventing you from actually making the maneuver in the first place. One problem that we get with some of these systems, particularly those fitted with cameras, are dangers. It's a kind of an extension on the side protection system, whereby it can detect any vehicles in your blind spot. Sometimes this is operated by using 2 smaller radar modules to the rear of the vehicle, looking out to the rear quarters of the vehicle rather than looking directly behind. It means that we can monitor all the lanes either side of the vehicle. An awful lot of cars now, particularly SUVs and 4x4 versions of vehicles, thing that the vehicle might come across on the road, including things like barriers and so on, and put that all together to create a 3D image, and then it can start to do calculations on what's going to be a problem to us ahead of the vehicle, or even to the sides and the rear of the vehicle, because we now need to have 360-degree imaging in order to know what is straight and what isn't. Just imagine when the vehicle's looking 250 plus meters up the road, it's a case that the vehicle might be actually looking in the wrong lane because it thinks it's looking in the lane ahead, but in actual fact, because the thrust angle of the vehicle is wrong, the vehicle is not looking in the right lane. This could mean as you go to overtake a vehicle on a motorway, or indeed as a vehicle overtakes you, your brakes could end up being slammed on because it thinks that vehicle is actually in your lane. It doesn't know any different, so it just slams the brakes on. So as you can imagine, this could lead to the radar detector or the LiDAR detector or the camera or whatever sensor it is that you're looking at isn't just a sensor, it's a computer in its own right. And in most cases, they actually are a node on either the CAN bus network or a special network for the ADAS system. So in some cases, you may get some form of sensor signal from them. So not only will you be measuring your powers and your grounds, but you'll then be looking for whatever sensor signal is going back, just working. But seemingly now, since you didn't buy the car new, you don't have the right necessarily to use all of those systems. There was an instance not so long ago where a customer in the US bought a second-hand Tesla, and when he registered it with Tesla, he went back to the car and found that half the stuff that was bought and paid for didn't work anymore. And so now it seems to be that you now buy a license to use this equipment when you